And in current electricity, we have finished a big amount of part in the previous class where I talked to you about what is the meaning of drift velocity, what is the relationship of current with drift velocity. I told you drift velocity is minus E tau by m, where negative sign indicates that electrons get drifted in the opposite direction to electric field, and small e is the basic elementary charge 1.6 × 10 to the power minus 19, capital E is the electric field, tau is the relaxation time, which is the average of all the time of successive collisions, and m is the mass of the electron. When you found the relationship between current and drift velocity, you got I is equal to NEA Vd, where Vd is the drift velocity and n is the number of electrons per unit volume, small e is the basic elementary charge, A is the area of cross section. Am I right? I by A is called as current density J, and I told you current density is defined as current per unit area A cos theta. So current is the dot product of current density and area vector, that is why current is a scalar quantity. Also I told you in the previous class, what is the formula of resistance? Harvish, you can mute yourself. What is the formula of resistance? I told resistance formula is R is equal to ml by ne square tau A. Am I right? Where m is the mass of the electron, L is the length of the conductor, n is the number of electrons per unit volume, that is electron density, E is the basic elementary charge, tau is the relaxation time, and A is the area of cross section. And you also learnt rho, which is resistivity, is equal to m by ne square tau, which makes it very clear that resistance depends upon length, area of cross section, nature of material and temperature, whereas the resistivity is depending only on two things, nature of material and temperature. It is independent of length and area of cross section. Then comes the concept of temperature dependence. I could teach you for a particular temperature what is the resistance or resistivity, where I told you the formula of rho T, which is equal to rho naught into 1 plus alpha T minus T naught, where rho T is the resistivity at temperature T, rho naught is the resistivity at room temperature, alpha is the thermal coefficient of resistivity, and T is the temperature at which you are finding the value of rho, and T naught is the room temperature taken as 27 degrees Celsius or 300 kelvins. Then I even gave you the graph for different materials for resistivity, the graph for conductors, that is for metals, graph for semiconductors and the graph for alloys. So for all of these things are very important for the board examination. Today our topic of discussion starts with one very interesting story. So I will tell you about a boy who was told to go to a shop, electrical shop, by his father. So a boy was told by his father to go and buy a battery, 9-volt battery. Some of you would have seen the 9-volt battery, that blue white color battery comes in the market, no? That battery, he told him to buy and come, and his father was a physicist. He is having all the devices in his home itself. He has voltmeter, ammeter, wires, multimeter, everything he has in his home. So he told, he is making some robot in home. So he told, you get me a 9-volt battery from market. He went to market, buys a 9-volt battery, comes to home. So his father is saying, whenever I am sending this boy outside, he is buying and something and he is getting cheated by the shopkeeper. Like if I am saying him go and buy 2 kg of mango, he goes and buys for 100 rupees per kg. If I am going and buying, it will be 80 rupees per kg only. He is not knowing to bargain. He is not getting good quality. This is general parents thinking about our, even for me. My father will go and ask me to buy something. When I am coming, he is saying, for how much rate you bought? I will say some X. He will say, I would have got for less rate than that. Or else, if I get something, he will say, how you have brought rotten potatoes? If I would have gone, I should have got good thing. General, I think most of you or some of you at least would have felt this, that whenever we get something, no, parents will always think it is not good. If they would have gone, they would have got better. The same thinking parent, conventional old parent, thought that this guy would have got cheated by the shopkeeper. He would have given him some old battery having some less voltage. So let me check it. Let me check it and let me confirm whether this boy has got been cheated by the shopkeeper or not. Took that battery, connected in a circuit, simple. Make a circuit in which you put sorry, I'll take white color, yes. So in the circuit, if you have some resistance and then you have a battery here and then you have a key, and if you connect a voltmeter across it and if you connect a ammeter in the series, this thing everybody knows from the 10th standard itself, diagram which you draw for Ohm's law experiment, isn't it? So we have a battery here, we have a key here, and we have ammeter, voltmeter, and here he has put the battery that the boy brought from the market. So it's obvious that if the battery is of 9 volts, then 9 volt is there, and what should be shown in the reading here was should be 9 volt, isn't it? Because what will drop here should be 9 volt only. Am I right? That's what the physics says. Physics says that whatever is the EMF of the cell, that much only can drop in the resistance, that is in the resistance. If you have multiple, it may drop 4, 5 or it may drop 2, 7 based upon the resistance value, but total potential dropped will be 9 volt. Okay. So he expected the reading on the voltmeter as 9 volt and he checked that, but he saw it was not 9 volt. As his father's doubt, he was very happy to find that my son has got cheated and it was coming as some 6 or 7 volts. I hope the story is clear to you. Now, I would like to ask you your suggestions, whether the boy has been really cheated or there is something else as the reason for this drop in the potential. Any idea? Or you think like the father of the boy that yes, the shopkeeper gave him some old battery, used battery, which is not having the good potential. What is your opinion? You may be right or wrong, but what is your opinion? Fast. What is your opinion? Yes. Pratap, please.
Not cheated, sir, because the wire might have some resistance.
Oh, very good.
Added to the resistor.
Yes, yes, very good, very good. So Mr. Pratap says that wire will have some resistance, sir. It would have got dropped there. Let me assume, Pratap, wire is having no resistance. Now?
I'm not sure about the drop in the resistance, sir, but I'm sure that it's not cheated.
Why you have trust on that boy?
No, not like that, sir, but I think I have experienced it somewhere, I guess.
Oh, you are that boy. Okay.
Not like that.
Good, good, good thinking. Yes, Mr. Sharan Ram.
Sir, I think voltmeter ammeter would be faulty, sir.
Oh, some more good logic is coming here. He is saying voltmeter itself is not good. His father is itself cheated by the person who sold voltmeter to him. Why the battery should be bad? Voltmeter itself is bad. Yes, Mr. Yogit.
He may be having some physical error, sir, the father.
Father having physical error.
By noting the values in wrong.
That is not physical error actually. Systematic error. Physical error, I thought like his father itself having some problem. While doing experiment, his hand shaked like that. No. Okay. So as per him, there is some error in the calculation. That's why the value is coming less. Anybody else? It's just a brainstorming. You may be right or wrong. Good, good, good. Some more inputs. What do you think could be the reason for this less voltage? Any idea, Mr. Niranjan? No? Give a try, man. Just tell me, man. Manoranjan.
Sir, maybe some resistance may be placed before the voltmeter.
Placed means who has placed? God has placed.
No, sir.
I have not placed.
Before,
I said wire has no resistance, okay? And I said there is no other resistance present. Then how it is dropping, man? Manoranjan. Good idea, good thinking. I appreciate. Yes, Mr. Yogit.
So it may be due to the temperature where it's recording the.
Okay. The temperature has varied, resistance has changed, so potential has changed. My dear Yogit, whatever resistance it may have, 1 ohm, 10 ohm, 100 ohm or 1 lakh ohm. If it is 9 volt battery, no, 9 volt only can drop here. Remember this. Current will change, potential will not change. Yes. Anybody else? Any other thinking? I hope no. Right? So, shall I tell the reason for this? Give the heading as internal resistance of the cell. Give the heading as internal resistance of a cell. I hope everybody knows that cell is made up of chemicals. I know most of you will be thinking by now, up to now, that when I go and buy a battery from a shop, that battery is giving that current to the circuit. Yes, many of you may think that when I am connecting, suppose I am glowing a bulb by this battery, bulb is glowing. Why the bulb is glowing when the battery is connected? There may be some charge in that. Charge starts to flow. Bulb is glowing. When the charge is not able to flow or the charge gets exhausted, the bulb will not glow. Many of you may have this thinking. I believe that a cell is giving the source of charge to the circuit. Don't say no sir, no sir. If I ask you many questions, if you say no sir. So many of you may have this thinking where you feel that any kind of battery is used to give charges to the circuit. Some of you may not, some of you are intelligent, you may know the exact reason for this. But that is not true. I hope you know, and if you don't know, let me tell you that a cell or a battery is just a source of EMF, electromotive force. So when you buy a cell from market, never think you have brought charges. You have just brought some chemical which is going to give energy for the electrons already lying in the wire to just start to move in a particular direction. By now you should know that if the electrons, if I am having a wire what, any metal, that metal or the wire will have by default electrons, but those electrons are not producing current because electrons are randomly moving here and there. It cannot be stationary. It is randomly moving here and there. If they are randomly moving here and there, the net velocity is 0 and so current is 0. This is the first class I taught this, last class. But the moment you are connecting a battery, we are getting what? We are getting a potential difference. So if I am having a battery of 9 volt, no, it means that the positive terminal is having a 9 volt of potential, the negative is having 0 volt. That's why the potential difference is 9 volt. Some of you may say, sir, 18 and 9, yeah, you can write. 20 and 9, 20 and 29, yes, you can write. Aim is to make the difference in potential between positive and negative as 9. Somebody is taking 90, they are also correct. Somebody is taking 109 and 100, they are also correct. Somebody is taking 1009 and 1000 is also correct. It just indicates that two terminals are having a potential difference of 9 volts. By this potential comes electric field, because you know that electric field is equal to electric potential by distance. This electric field drives the electron in the same direction and the current is produced. So battery is not giving any charge. Battery is just giving the potential difference for the electrons to move across the circuit. I hope you get my point. And why the battery is over? When the battery is not able to give the energy for the electrons to move. Are you getting my point? All its energy is exhausted. Then we say battery is over. Which energy? The chemical energy. Chemicals can no longer react. We say battery is dead. Because battery is what? Chemicals. Lithium ion battery, nickel cadmium battery, all these are chemicals inside. They are reacting and producing energy. And chemical energy is getting converted into the electrical energy. If chemical energy stops, how it can stop? All the reaction is over. Reaction always happens for a fixed time, isn't it? After that it is over. Yeah, if you have a rechargeable battery, you can once again charge it. Otherwise, throw the battery and buy a new battery. Am I right? If you are having a battery which is completely exhausted, you will throw it and buy a new battery. So, when you are buying a battery, that battery has chemicals inside it. Nowadays, we have advanced batteries, powder chemicals are there. Earlier, we used to have liquid chemicals, liquid electrolyte is there, cathode, anode. All of you would have studied about these things in electrochemistry or maybe earlier part also. Like Lange's cell, Daniel's cell, am I right? Somewhere you have studied about these things, and you must know that it has a cathode, anode, electrolyte, charge moves from this to this. These things you have studied, right? So, what is electrolyte? Electrolyte is a chemical which may be in liquid form or it may be in solid form today. Nowadays, powder form electrolytes are there. This electrolyte is having some internal resistance, and because of these electrolytes in the cell only, there is some internal resistance which is given by a letter small r. So, this guy bought a battery which had some R of suppose 1 ohm, okay, and his father connected with suppose a resistance of 7 or 8 for easy calculation, 8 ohm. Then what is the total resistance? 9 ohms. So, what is the current? I is equal to V by R. So, V is how much? 9, R is how much? 9, how much? 1 ampere. So, if 1 ampere current starts from here, how much will drop here? Only 8 volt will drop here. So, it will show how much volts? Only 8 volts. Remaining 1 volt, where it dropped? It dropped inside the cell itself. Yes, Sharan.
How can we say that the cell can have that any reason?
I don't know, reason is electrolyte. The chemicals inside the cell, they are offering some resistance towards the movement of charge. That resistance offered by the electrolyte is only called as internal resistance of cell. If you would have seen many cells are there, many companies are Eveready battery is there, Nippon battery is there, Duracell battery is there. So, by default our mind thinks Duracell will be better, don't you think so? You see, you think that Duracell will be better. Why? It will have less internal resistance, because it is made in more controlled environment. They are using the chemicals in such a way that it has least internal resistance. That is why it is preferred over other companies. It is costly also. 10 rupees you will get Eveready, 50 rupees you will get same Duracell. Are you getting my point? So, the battery, because of the electrolyte present inside the cell, by default has internal resistance, which we are not able to see from outside. So, whatever potential it was not shown in the voltmeter, that potential dropped where? Inside this cell itself. That is why his father got a lesser value of voltage compared to what he was expecting. I hope everybody agrees to what I said now. Now, you can write definition. All of you please write definition first. It is the resistance offered by, it is the resistance, Sai Rakshana, if you are there in the class, I hope you are writing. Your face looks like you are seeing something else. What I told? It is a resistance offered by the electrolyte, present inside a cell, It is denoted by, you can write small r. It is denoted by small r. It is denoted by small r. Right. Now, something very important coming, please pay attention. So, I came to know, I took an example, I am just drawing a cell like this, where I am having a cell and I am drawing a small r here itself. This is the EMF of the battery and this is the external resistance R. The potential drop across this I am writing it as V, okay, and the current which is flowing through it is I. This diagram is clear to you? I am having a battery having EMF of E, I am having external resistance capital R, and just now I taught you the cell or the battery itself will have a internal resistance small r. Now, everybody can understand that this EMF E will become equal to V plus IR. Do you agree with me? EMF E will become equal to V plus IR. What is V? The potential dropped across the external resistance. What is IR? Potential dropped across the internal resistance. Am I right? So what is V? V is potential drop across external resistance. External resistance. And what is IR? It is the potential drop across internal resistance. Now, if we rearrange the term, I can write V is equal to E minus IR. For your knowledge, V, which is the potential drop across the external resistance, has another name. What is that? Anybody knows? Anybody knows? Very good, Devadarshan. It is called as terminal voltage. It is called as terminal voltage. So you are learning a new term now. Already you are learning electromotive force EMF. Already you learned potential difference V. Now one new thing is coming, terminal voltage V. Now how are they different from each other? Electromotive force is the external source of EMF, that is, which we are providing for the circuit to start operating. Terminal voltage is the total potential drop across the external resistance, and potential difference is the difference of potential between any 2 points. I hope you are getting my point. Suppose I am having a circuit like this. What we are giving externally is called as EMF. What potential drops totally is called as terminal voltage. And if I talk about this point, this will be potential difference. If I talk about this point and this point, it is potential difference. Are you getting my point? So potential difference can be equal to terminal voltage also. When? If we are having total potential difference. Like this case, only one resistance is there. So here what is the potential difference and what is the terminal voltage is same. Please don't get confused in all these terms. Electromotive force is the external supply, what you are putting in a circuit. EMF is that thing. Terminal voltage is what is the potential drop happening in the external resistance overall, and potential difference can be for 2 given points. It can be anywhere to 2 points. I hope it is clear. So this is the relationship between terminal voltage and EMF when the cell is getting discharged. This is for cell getting what? Discharged. And we can also be written as E plus IR. See, when you have rechargeable batteries like mobile phone battery gets discharged, you will throw it, you will charge it, no? Why? Because it has a capability of getting charged once again. In that case, V will become equal to E plus IR. So this is the formula when the cell is getting charged. So while charging, the V is equal to E plus IR, while discharging, V is equal to E minus IR. It's important for the examination. Very important topic today we are dealing. V is equal to E plus IR, V is equal to E minus IR. Where V is the terminal voltage, E is the EMF of the cell, I is the current flowing through the battery, and small r is the internal resistance of the cell. I hope it is clear. Can I proceed further? Have you copied everything from the board?
Sir, just one.
Make it fast.
Sir, can you tell the definition for terminal voltage, sir?
Write it down. It is the potential drop across the external resistances across the external resistances when the circuit is closed, when the circuit is closed, when the circuit is closed. Written? Now can I proceed further? Just now starting cells. Shall I proceed? I hope I can. If anybody has any problem, you can ask me. Okay. So now you came to know that in a particular, like I can tell here itself, that in this case, if I want to find what is the current in this circuit, what will be that? EMF divided by R plus R. Don't you think so? Current drawn from cell will be how much here? EMF that I am applying divided by total resistance R plus R. This is the formula how we are finding current. I is equal to E by R plus R. Okay. Can I proceed further? Shall I? I want to take a question from here at this point of time. One question that may be there in somewhere downloads the book. I had my last class on which day? Yeah. Yes, guys. So now I think you can take an attempt for this question. Question number 1 and 2. Fast, fast, fast and very fast. 3.1, 3.2. If you have book in your hand, you can directly use the book to solve. Otherwise, the board is in front of you. Question 1 and question 2. Can you try it? I will help you if you are not able to solve it. Just based on whatever I have taught now. Based on whatever I have taught now. Make it fast. Question 1 and question 2. Don't take more than 5 minutes, please. Anshul, why is your camera off?
Sir, I don't have the textbook. I'm just viewing the question properly.
Okay, okay, fast, fast.
Sir, is the third question should be solved?
No, 1 and 2 alone.
Okay.
You have NCERT book, right, Anshul?
No, sir. I didn't get it yet.
Or did not get from school yet?
No, sir. Like one of my senior told he will give it.
He will give it, but you are waiting for him to give it.
Yes, sir.
Okay, then you will get next year only, I think, right? Get it fast, man.
Right. Sure, sir.
Hmm. Done both? Match the answer from the back. I hope there is no doubt in these two questions, very basic questions, NCERT. I'll help you if you have any problem. First question was EMF is 12 volt, small r is 0.4 ohms. What is the maximum current that a battery can be drawn from the battery? What is the answer? How did you get that?
E by R plus capital R.
Hmm.
Sir,
Yes, please tell me, Pratap.
assuming that we don't have any external resistance and having only the internal resistance of 0.4 ohm,
Yeah.
we are getting 30 amperes.
That's all, simple, nothing is there in this question itself. 12 by 0.4 will give you 30. That is all the answer is. If you have some extra resistance, it will reduce the value of current, that's all. Maximum current, how much it can draw? Only 30 ampere. Are you getting my point? If you are going to connect any kind of resistance externally, then it is going to draw a current lesser than 30 ampere only. Are you getting my point? Okay. Question number 2. EMF 10 volt, small r 3 ohm and R not given. If the circuit is current is 0.5, what is the resistance of the resistor? I is equal to E by R plus R. I is given as 0.5 is equal to 10 by 3 plus R. Solve that equation, you will get the value of R as 17 ohms. Yeah, very good, correct. Then they are asking what is the terminal voltage of battery when the circuit is closed. So yes, so you did that multiplication, you will how much you are getting? Matching with the book back? Done? Don't think any of the one can come in the examination. It can never, just to boost your confidence. Even though it is an NCERT book, it has no much value more than to encourage you that yes, we can do it. Fine. So shall we proceed further? Now let me make the things little complex, shall I? Up to now we are in the good part of this chapter. Shall we start with some difficult part? Okay, like how you have seen capacitors getting connected in series and parallel, like how you are going to see resistance going to get connected in series and parallel, we also have cells in series and parallel, cells in series and parallel. Okay. So, most of you would have seen remotes in your home. It can be a TV remote, it can be a AC remote, it can be toy remote, any remote it may be. This remote has two cells. Do you agree with me? Here and here, there are two cells. They are connected. Are they connected in series or parallel? Common sense, layman, the one who has never gone to school can also say that they are parallel. What? You are saying series? What, Shweta? Tell, yeah, what you are thinking. You think it is series because I am asking this question. If he is asking, something fishy will be there. So let me say the answer which is not going to be there. Good way of understanding. I will ask you explain how it is parallel. Series. Parallel, layman will understand parallel. Two lines are parallel. But if you are saying series, I will ask you how it is in series. Explain me. Don't know. Then you should not say it is series. Again I am repeating, don't try to play brain game. That anyhow he is going to say the answer which is not going to be there. So it is series. I am asking about layman common sense. Says it is parallel. Yeah, but as Shweta is thinking and as I am asking this question to you, the answer is not parallel. The answer is series. But today, by this end of this class, you will understand what is the meaning of series connection, what is the meaning of parallel connection, when are we going for series connection and are we going at all for parallel connection, and if we are going for parallel connection, then where are we going for parallel connection. Okay? So understand what is the meaning of series connection first. Series connection means the negative of one cell is going to be connected to positive of other cell. That is negative, positive, negative, positive, negative, positive. This kind of connection is called as what connection? Series connection. We also have a possibility that all the negative terminals are connected together and all the positive terminals are connected together. This kind of connection is called as parallel connection. So what is the meaning of series connection? Plus, minus, plus, minus, plus, minus. And what is the meaning of parallel connection? All negatives together, all positive together. It means a parallel connection. Is it clear to you? Now, how I am justifying that the battery in the remote is in series connection? See, if you remember the battery connection, one side we will have spring, right? One side we will have this plate, and then here we will have spring, and here we will have plate, right? I believe most of the remotes are like this only, isn't it? Until it is straight single line, then also negative, positive only. If it is like this, if somebody has broken the remote or taken out this thing, they will remember that here you are going to have single plate and here you are going to have single plate, right? They are attached. So when you are going to put a battery here, this is how you put the battery, and this is the positive terminal, this is the negative terminal, am I right? And this positive is connected like this now, am I right? Negative, positive. So how you connect it, you see? Negative, positive, negative, positive. What connection is this? Understanding my point? Because these two are connected in a way. Why the plate is there? Why can't they make separate itself? Then no connection will be there. This means here you have negative, positive, negative, positive. That's something like that. I hope you are understanding this. First, to understand the meaning of series, meaning of parallel. Okay. Now we will go to the deep of this. So suppose just now we learnt if we have cells, it will have internal resistance. Today we are in a very complicated part. Remember that. If you miss the tension, you miss the topic. So be attentive. So I am having one resistance, internal resistance R1, again one cell, internal resistance R2. Let me take 2 for solving. This is having value R1, this is having value R2, this is having EMF E1, this is having EMF E2, and I hope you believe they are in series connection because negative, positive, negative, positive. Okay. Now, if I take the point here as A, if I take a point here as B, if I take a point here as C, then I can understand very, very, very clearly that VAB is equal to what? VA minus VB, that is the potential difference. And what is that VAB, terminal voltage across AB? E minus IR, am I right? It's now learnt V is equal to E1 minus IR1. Do you agree with me? In series, current remains same. Same way, if I take BC, VBC will become equal to VB minus VC, which will become equal to E2 minus IR2. Do you agree with me? Do you agree with me? Any problem? If I want to write VAC, that will become equal to VA minus VC. I cannot write in that form until I make a equivalent of it. If you make an equivalent of it, then it will become like this, where is having value of R equivalent and is having value of E equivalent. This point is A, this point is C. So I can write the value of VAC as equal to E equivalent minus I into R equivalent. But here if I want to write VAC, I can write in a way that these both can be used. You know what I will do? I will add VB and subtract VB. Now see what it becomes simple. Now it became VA minus VB plus VB minus VC. Don't you think so? Anybody has doubt in what I have done? Very basic calculation. I have just added VB, subtracted VB. Now it becomes, I think, quite simple, because I have the value of VA minus VB. How much is that? E1 minus IR1. So VAC becomes equal to E1 minus IR1. And what is VB minus VC? E2 minus IR2. Any problem in this? You should not have. VAC will become equal to E1 plus E2 minus I into R1 plus R2. I hope online people are able to see my board till the last. So I get the value of VAC as E1 plus E2 minus I into R1 plus R2, and VAC is also equal to E equivalent minus I into R equivalent. Now tell me, from equation 1 and 2, what do you get? You get E equivalent is equal to E1 plus E2, and you get R equivalent is equal to R1 plus R2. So interesting thing is, if cells are connected in series, net equivalent EMF will be the addition of individual EMF. So I have 5 cells connected in series, net EMF will be E1 plus E2 plus E3 plus E4 plus E5, and net resistance will be R1 plus R2 plus R3 plus R4 plus R5. Any problem in this? Common sense, we derived it, proved it. Now the problem is, what will happen? Just try to imagine what will happen if I have a connection like this. E1, E2, E3, E4, it is having resistance R1, it is having resistance R2, it is having resistance R3, it is having resistance R4. Do you think that in this case E equivalent will become equal to E1 plus E2 plus E3 plus E4? No, because here one cell is in opposite direction, not parallel here. Parallel means or negative together or positive together. Here only positive positives together. Negative negatives together, eh? No, right? We cannot say parallel. But we can say that one cell is wrongly connected, oppositely connected. If this happens, that cell becomes negative, EMF. So it will become equal to E1 plus E2 plus E3 minus E4. Keep this in your head. Numericals are coming in competitive exam also from here. What will happen to R equivalent? R1 plus R2 plus R3 minus R4. Why? Yeah, resistance can never become negative. That will remain same.
So it will be positive only, right?
Yes, obviously positive, Mr. Pratap. R1 plus R2 plus R3 plus R4. If cells are connected in series, their EMFs are added, their R is added, but if one cell or two cell is connected in the opposite direction, that EMF will be subtracted, but their internal resistance will still get added. I hope it is clear to you. If yes, please copy it fast, then we will move to parallel connection. Parallel is going to be little interesting. Copy it fast, 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 fast. Don't take much time. Today the climate inside is fine, right? I think that we have changed the AC point, now it has become fine.
Yes,
It is not that hot like earlier days, no?
yes.
So I think it is working now. Able to see the board? You can move little more, you move. Shark. Make it fast. Ravan sir, you can unmute me. Make it fast, guys. Saravanan I disappeared.
That's
Done? Everybody else? Little fast, please. Where is your friend Aditya Raj?
Sir, he's absent.
That I also
Yes.
see.
Tomorrow we have exam.
Which exam you have?
Inter.
Which subject?
Physics.
Which topic?
First chapter.
Okay. Oh, that's why this people, even that Mithun has taken permission for not coming today. Deepa Jyoti. Unmute yourself. What is the, why suddenly you disappeared?
A message popped up like leave the meeting, something came, sir.
From host.
Yes, sir.
Oh my God. Okay. Fine. Anything happens like that, immediately you should message me or call me. You missed some 1 hour of class.
Yes, sir.
Okay. Anyhow, you can continue seeing and you can see the video of what you have missed. Okay.
Okay, sir.
We are talking about cells in series and parallel, and I have talked about cells in series. I am going to talk about cells in parallel now. I hope you try to understand whatever I teach. If any problem is there, you can ask me. Can I proceed further? Guys, can I proceed further? Written? Farzana? Proceed, no? Okay. So, now we are going to talk about cells in parallel. Cells in parallel. Okay. So, I said you before some time, cells in parallel means all the negative together, all the positive together. Okay. So, if I am having like this, this connection is called as what? Parallel connection. Okay. Let it have EMF E1, let it have EMF E2, let internal resistance R1, let it be R2 here. Again I am repeating, please don't try to copy now. I will give time for writing. Focus on understanding the concept. It is something which is little complicated to understand if you don't understand properly. So focus on listening. I will give time for writing. Right, Kirti? Please pay attention. So we have 2 points, like point here A, point here B. Now what is VAB? Tell me the formula. VAB will become equal to VA minus VB. Okay, fine, no problem in that. And which is equal to E1 minus, first of all, parallel connection. Current going here will be I1 and current going here will be I2. So V will become equal to E1 minus I1 R1. Can I say like that? Okay. If somebody is saying VAB is also equal to E2 minus I1 I2 R2, are they wrong? If somebody is saying VAB is equal to E1 minus I1 R1. Other person is saying VAB is equal to E2 minus I2 R2. They both are correct because potential is same for parallel connection. Never forget this: capacitor, resistor, cell, inductor, any electrical device in parallel connection will have same potential. So I can say that instead of writing all these VA, VB, confusing yourself, just be simple. V can be written as E1 minus I1 R1, or it can also be written as E2 minus I2 R2. From here I would be getting I1 is equal to E1 minus V by R1. Do you agree with me? Any problem, please ask me. I hope no. And from here I am going to get I2 is equal to what minus what? E2 minus V by R2. Again I am repeating, be in the class, have concentration here. Copying is not what you are coming for. Notes, I can give you written notes, very beautifully written notes. I have my old students' notes who have written very good. I can share with you the PDF also if you want. Notes are secondary. Please pay attention on learning what is happening. Okay, coming back. So I1 we got, I2 we got. So we understand that the current going inside I is equal to I1 plus I2, isn't it? Whatever current was going, that current only has become I1, I2, no yaar? Net current is equal to what plus what? I1 plus I2. And if I draw an equivalent circuit for this, which is A, B, E equivalent, R equivalent, then this VAB, which is also equal to V, can be written as I minus, sorry, why I minus I am writing? E minus IR. So E E equivalent minus I into R equivalent. This is the basic thing which we know from our understanding of this V, isn't it? Any problem in this? Any problem in this? So, coming back, we have got I is equal to I1 plus I2. So, I will write I as, what is I1? E1 minus V by R1 plus E2 minus V by R2. Now, I will solve very simple, step by step I will solve. I will assume that you are very weak in math and I will solve like that. Okay. So, I will become equal to E1 by R1 minus V by R1 plus E2 by R2 minus V by R2. Am I right? I have taken the denominator separate for both the terms. So, I will become equal to, I will write these two together, E1 by R1 plus E2 by R2 minus V into 1 by R1 plus 1 by R2. Do you agree with me? Do you agree with me? Should. I is equal to E1 R2 plus E2 R1 by R1 R2 minus V into R2 plus R1 by I can once again rearrange V is equal to, because I want to get in that format for comparison, V is equal to E minus IR. So, V, I know many of you will not understand, so I will write very simple steps. So, V into R2 plus R1 by R1 R2 is equal to what? E1 R2 plus E2 R1 by R1 R2 minus I. Do you agree with me? Anybody has any problem in this? Any problem is there in this? Let me once again send this side, this term. Why I am doing, I don't know. So, V will become equal to, I will take the next page here, too much of gachmacha will happen here. So, I will go to the next page. V will become equal to what? See from here and tell me. V will become equal to, leave it. Extra pen is there. V will become equal to, E1 R2 plus E2 R1, E1 R2 plus E2 R1 by R1 R2, and this will come this side, it will become R1 R2 above divided by R1 plus R2, right? Yeah, I am going to, I am not ending here, I am writing is checking this expression, and that time also is there, minus I into the same thing, isn't it? Which is R1 R2 will come above divided by R1 plus R2. Understanding? If you are knowing at least addition, subtraction, changing of terms, you are understanding. Not understanding? Then work on your basics. These two gets cancelled. I get V is equal to E1 R2 plus E2. I am done doing correctly or some mistake I have done? Huh? Something, everything is going fine, no? Yeah? Minus I into R1 R2 by R1 plus. I hope everything is going fine. I have faith. Now compare this with what? Equation number 1, equation number 2. So from 1 and 2. From 1 and 2. What do you get? E equivalent is equal to E1 R2. Why I have this problem? Everything is fine, no? No mistake you have done here in calculation? Okay, let us see. E1 R2 plus E2 R1 by R1 plus R2, and we get R equivalent is equal to R1 R2 by R1 plus R2. Okay, no problem, no issues. So from here we get very clearly one thing, that since R equivalent is equal to R1 R2 by R1 plus R2, 1 by R equivalent is equal to what? 1 by R1 plus 1 by R2. Do you agree with me? Do you agree with me? If you doubt, I can make you understand one more step also. I write 1 by R equivalent will become R1 R2 by R1 plus R2, gets cancelled, no need of that much, no? Okay. And if I am doing E equivalent by R equivalent, what you get, you check. E equivalent is E1 R2 plus E1 R1 by R1 plus R2. It has to be divided by what? R equivalent. What is R equivalent? R1 R2 by,
Excuse me, sir.
tell me, man.
Sir, E1 R2 plus E2 R1, right?
Yeah, man. Good concentration.
Okay, sir.
R1 plus R2 gets cancelled, and we get E equivalent by R equivalent as what? E1 R2 space itself not sufficient. This is itself, yeah. So E equivalent, what my pen is lying there, yeah, E equivalent by R equivalent is equal to E1 R2 plus E2 R1 by R1 R2. So if I open this, it will become E equivalent by R equivalent is equal to E1 by R1 plus E2 by R2. You know what we understand from here? We understand that if cells are in parallel, you cannot find the value of E equivalent until you have the value of R equivalent. In the case of series connection, E1 known to you, E2 known to you, add them, you will get E equivalent. In parallel connection, E1 known to you, E2 known to you, can you find E equivalent? Because E equivalent by R equivalent is equal to E1 by R1 plus E2 by R2. So you have to find the value of R equivalent, then only you can put in this formula to get the value of E equivalent. I hope you understand this. In series connection, if I am having 5 cells, net EMF will be E1 plus E2 plus E3 plus E4 plus E5, and net internal resistance will be R1 plus R2 plus R3 plus R4 plus R5. If you have parallel connection, resistance behaves the same way. 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4 plus 1 by R5. But can we do E equivalent also same way? No. Don't use 1 by E equivalent is equal to 1 by E1 plus 1 by, no, we cannot use that formula. E equivalent by R equivalent will become equal to E1 by R1 plus E2 by R2 plus E3 by R3, E4 by R4, E5 by R5, and then only you can find the value of E equivalent. If there is any problem, ask me. If there is no problem, copy from the board. Okay? I will give 5 minutes of time, copy fast, then I will go to the next page. I am giving 5 minutes of time, copy fast, then I will go to the next page. Careful. I'll take it. No. Thank you. Please make it fast. Can I go to the next page? Okay, Sai, Rakshana, you can come, no issues. I hope you have copied. Done. Can I proceed?
Yes, sir.
Okay. Others here? Done, Vignesh? Badri, what about you? Make it fast. Ritunjay, copied? Yes. Tell me, Pratap.
Sir, what if, like, if we reverse the charges also, the value will be same, right, sir?
If we
If we reverse the cell, like the positive side negative and the negative side positive, the value will be same only, right, sir?
you are saying that if you connect like this,
So what we did in the series, sir?
understood? You are saying like this, no? Am I right?
Yes, sir.
How now?
It becomes
No. Yeah, it becomes series, man. Check what happened. Positive
Yes, sir.
to negative, positive to negative, isn't it?
Yes, sir.
The connection itself changed.
Yes, sir.
Okay.
Once I saw the diagram, I can understand.
Yeah. So I can proceed further. I taught to you.
Yes, sir.
Yes, I taught to you how the cells will behave when they are in series, how the cell behaves when they are in parallel. So cells when they are in series, their net equivalent EMF are added. When they are in parallel, their net equivalent EMF by R equivalent is equal to E1 by R1 plus E2 by R2 and so on. Now the question is, are we going for cells in parallel or we always go for cells in series? It's not like that. There are conditions when we even go for parallel connection of cells, and there are conditions when we go for series connection of cell. Now we are going to learn when are we going to connect the series connection of cells and when are we going to have the parallel connection of cell. Very important topic again. You understood now series and parallel connection, but now you should understand when are we going to go for series, when are we going to go for parallel, And questions from here come in the board examination in the category of assertion and reasoning. Okay? It won't come in numerical mostly, it will come only in A and R. Mostly from my experience I am saying you, it comes in A and R. Coming back. So, imagine, everybody pay attention, I will give time for copying. Imagine we have many identical cells and all of them are connected in series. Understand? So, there are n cells which are connected in what? Connected in series. And they are connected to an external resistance R. I am repeating, everybody pay attention. I am having n cells and identical cells. Identical cells means everything is having E, and everything is having small r, small r, small r, small r. And they are connected in series. Now, if I ask you, what is the R equivalent? What will be your answer? NR, R1 what? R plus R plus R plus R, n times NR. What is E equivalent? NE. Don't you agree with me? Okay. So, what will be the current drawn from the cell I? Total EMF, which is NE, total resistance will be NR plus R, isn't it? Because we have external resistance also, no? I hope you are understanding how I have got this equation. I is equal to NE, which is total EMF, divided by external resistance plus total internal resistance. I hope everybody is clear in this. Now, there are two possibilities. One possibility is, if NR is much more than R, that is, total internal resistance is much higher than the external resistance. What happens then? Let us see what happens then. Then I will become equal to, R can be neglected because it is much smaller. So, I can write N into E by N into R, and N gets cancelled. I will become equal to E by R. It means, if you have n cells, even if you have 1000 cells connected in series in such a way that the net resistance of these 1000 cells is much greater than the resistance of the external resistance, then the current drawn by it is just like current drawn from one battery, one cell. Now, second condition, if R is much more than NR, what is going to happen? I will become equal to NE by, gets cancelled, R. So, I will become equal to N times of E by R, isn't it? So, current will be N times, if you have 1000 cells, it will become 1000 times E by R. Okay. Now, what I am going to do? I am going to have many cells, many cells connected in what? Parallel, and they are connected to a external resistance R. Since I have taken N in series, I am taking here M cells. M cells in what? Parallel. You know that if it is E, then in parallel connection, the EMF will become E. That is why I am having same EMF. So, now what is the net equivalent EMF you have? E. What is the net equivalent resistance? We can find 1 by R equivalent is equal to 1 by R plus 1 by R up to how much times? M times. So, can I say that 1 by R equivalent is equal to M by R? M into 1 by R, and R equivalent will become equal to what? R by M. So, what is the current drawn from this circuit? Net EMF is E by R plus R by M. If you take the LCM, then you will get the value of I as what by what? E, and M will go above, divided by MR plus R. Now, once again we have two conditions. One condition is what? If MR is much more than R, what will happen to I? R will get cancelled, so E by R. And second condition, if R is much more than MR, what is going to happen? I will become equal to m times of E by R. Do you agree with me? Do you agree with me? It is a very simple concept. Whenever, please pay attention, whenever net external resistance is more than the internal resistance, it is preferable to go in series connection. And whenever external resistance is less than internal resistance, then you go for parallel connection of cells. Because if internal resistance is much more than external resistance, then the current drawn will be m times of E by R. Are you getting? When are we going for series, when are we going for parallel? Generally, mostly external resistance only is more than the internal resistance. So, what you go? You go for series connection. But if you have scenarios where external resistance is less than the internal resistance, in those kind of devices, electrical devices, we can go for even parallel connection. If you are understanding this concept, copy it fast, already time is not much. First copy it. I will talk about something more now. Done?
Yes, sir.
Okay. Everybody here?
Sir, just a minute, sir.
Done? Everybody? you must have a doubt if you are really learning that when external resistance is much more than internal resistance, we go for series connection. When external resistance is much less than internal resistance, we go for parallel connection. What if they both are equal? What if R is equal to NR? That is the total internal resistance and total external resistance is same. What is best, series or parallel?
Sir, series,
Series.
because less wire is used.
No. What, Pratap? Something?
Wire,
Come again.
so if both the resistance are equal, then will there be any current drawn, sir?
It will be,
I guess it will be zero. The current drawn.
no, that will not be happening. I am asking the preferences. When we go, see, our aim is to draw the maximum current. So, for drawing maximum current, we are going for this series connection for external resistance more than internal resistance, and we are going for parallel connection when internal resistance is more than the external resistance. If they both are equal, we will go for mixed grouping. Not that in our syllabus actually, where we will have some series connection, that is series like this, and also parallel connection. Are you getting a point? This grouping is called as mixed grouping, where you have series also, parallel also. So, you go for mixed grouping whenever we have external resistance very similar to net internal resistance. Now, I am going to stop my class for the day today, but there are some doubts that some people have asked me from the worksheet that was given in the last class. That is, yesterday some worksheet was given in the offline class also, and it was also given in the live class. So, I think that worksheet, some doubts were there, and let me take that doubts for you now. What has happened? They are asking for permission. So, there are two questions that I am going to take now. This is yesterday's worksheet. I think Varshita Shri, you have asked something, and Kalai Chelvan, you have also asked something. Now, this worksheet is not given to SSM Nagar yet, so you may have some problem in understanding this. If you want, you can listen, or those who want to drop can even drop from the meeting, your wish completely. God's grace, fine. Where it went? Yes. So, you have asked question number 7, Kalai Chelvan, right? Am I right?
Yes, sir.
Yeah, question number 7 is not that difficult. 7 you have asked and 13 you have asked. I will go for both 7 and 13. I think 13 she also asked, Varshita she also asked 13 only. So, 7th question is the parallel plate capacitor has plates of area 200 centimeter square and separation between the plate is 1 millimeter, and they are asking you to find what is the potential difference if 1 nanocoulomb charge is given to the capacitor. So, I hope you know the capacity of capacitor, right, Mr. Kalechelvan? What is the formula?
Sir.
C is equal to epsilon naught A by D. Are you aware about this?
Sir, the last topic you taught in that chapter, that one, right, sir?
Exactly, not last, I have taught in the middle itself, and last topic I taught was about dielectric slab inside the capacitor. But yes, this formula is there. C is equal to epsilon naught A by D, where A is the area of the plates and D is the separation between the plates. So, here they have given the value of area also and separation also. Take in units, that is 1 into 10 to the power minus 3 meter square, and here it will meter actually, not square, meter, and here it will become equal to 200 into 10 to the power minus 4 meter square. Square is there, no, minus 4 meter square. So, area is given, D is given, epsilon is given 8.85 10 to the minus 12. Solve, you will get the value of capacitance, right? Kalechelvan?
Yes, sir.
After finding capacitance, you know that Q is equal to CV. Aware about this formula?
Yes, sir.
So, Q is given as 1 nanocoulomb, which will become equal to 1 into 10 to the power minus 9 coulomb. Put the value of Q here, put the value of C here, you will get potential difference. Got my point?
Okay, sir.
Next
Yes,
is
sir.
if the plate separation is now increased to 2 mm. If that happens, they are saying that D is increased by 2 times, am I right?
Yes, sir.
Instead of 1 mm, it became 2 mm. If D becomes 2 times, then C will reduce by 2 times. If C will reduce by 2 times, then V is equal to Q by C, then V will increase by 2 times. Understand this concept?
Yes,
If the D is increased by 2 times, C is going to reduce by 2 times. If C is going to reduce by 2 times, V is going to increase by 2 times. Whatever answer you get here, multiply by 2, you will get the answer for this question. Are you getting what I have done, Kalechelvan?
sir.
Clear?
Yes, sir.
Sure?
Yes, sir.
Okay. If yes, then I will go to the question number 13, which I think many would have doubt. If it's a good question actually. Where the first part of the question I have spent a lot of time with you to make you understand. If you see that video also, you will have a clarity about this. Again, I am repeating this. I talked about the dipole moment of 2 kinds of molecule, polar molecules and non-polar molecules. I said that polar molecules are those whose dipole moment is not 0 if you take a particular molecule. For example, if you take H2O, it's a polar molecule. Its dipole moment will be not 0. Why it will not be 0? Because there is separation between their negative and positive centers. If you take oxygen molecule, it will have 0 dipole moment. Reason is there is no separation between its negative and positive centers. So, dipole moment of a polar substance, polar molecule is going to be having some value that is not 0, and dipole moment of a non-polar molecule is going to be 0. Now, when you are going to, I have talked about absence of external electric field. So, in absence of external electric field, a polar molecule has dipole moment and non-polar molecule has no dipole moment. But if you have a substance made up of polar molecule, its dipole moment is also 0. Why? Because dipoles are arranged in random direction, net dipole moment is 0. And net dipole moment will obviously be 0 for a non-polar molecule substance. Second part, presence of external electric field. If you have electric field, then the polar molecule substance will now have some dipole moment, because all dipoles will arrange its molecules in the direction of electric field. So it will have some dipole moment. And in the case of non-polar molecules, the dipoles will have some separation now. Dipole was not there actually, but what will happen? Their positive and negative center were lying in the same point, but now see what is going to happen. Positive and negative are in the same point, but since it is kept in the electric field, the positive will be moving in direction of electric field, negative in the opposite direction of electric field. This will create some separation between them, so they will also have dipole moment. It means that if I take a polar molecule, dipole moment exists. Non-polar molecule, dipole moment does not exist. Substance made up of polar molecule, dipole moment does not exist. Substance made up of non-polar molecules, dipole moment does not exist. If we are subjecting both of them to external electric field, then substance which is made up of polar molecules will have dipole moment now, and substance made up of non-polar molecules will also have dipole moment now. This story only you should write in paragraph wise in this case, first part. Is it clear, Class XII and Varshita Shri? Is it clear to you, the story what you have to write here? It's a 5-mark question here, so that story will fetch you 3 marks and 2 marks for this. What is that? Given two parallel conducting plates of area A and charge densities plus sigma and minus sigma. Okay, so here they have drawn the diagram. So here they are having plus sigma minus sigma means we will have uniform electric field. Okay. Now what they are telling? Dielectric slab of constant K and a conducting slab of thickness D, each are inserted in between them as shown. Find potential difference between the plate. Okay, fine. See here. Please pay attention. You know very well that electric field is what? Electric field is potential times distance. Am I right? Because potential is equal to electric field by distance. Now, please, for God's sake, pay attention. That electric, they are asking to find what? Potential?
You're supposed to graph the electric field.
Exactly. One second. E is equal to dV by dr. Actually, I have written wrongly. Electric potential only will become equal to electric field into distance, isn't it? Because E is equal to potential by distance. Am I right? So potential will become equal to electric field times distance. So now electric field is known to us. You know very well, if you have two charged plates, plus sigma and minus sigma, between them we will have electric field E naught. How much is the value you know? Sigma by epsilon naught. By now you should know all these things. First chapter you studied this. So that electric field will be there, but where it will not be there, in this area it will be different, because I told you whenever a conductor is placed, the electric field becomes 0, and whenever dielectric is placed, electric field is reduced. How much it is reduced? By dielectric constant times. So here the electric field will become whatever is maximum value divided by K. These things I have taught to you. So if you want to understand this, you should go to my lecture and see how I have explained this to you. Whenever we keep a dielectric inside a capacitor, it reduces the electric field by how much times? K times. So now in this region, what is the value of electric potential? V will become equal to E naught into D. In this region, what is the value of potential? It will be E naught by K into D. In this region, once again, E naught into D. In this region, 0. And in this region, E naught into D. So we have E naught into D, E naught D, E naught D, it will become 3 times of E naught D plus E naught, actually it's not epsilon naught here, don't confuse, I have it writing like this, you may confuse also. E naught by K into D. This is the answer for the first part of this question. Second part they are asking, I hope it is clear to you. Class XII and Varshita Shri, is it clear to you what I have done now?
Yes, sir.
Can I proceed further? Class XII understanding?
Yes, sir.
I hope. Second part
Yes,
is
sir.
plot E versus X graph taking X is equal to 0 at the positive plate. Okay. So what they are asking, draw a graph like this, and this positive plate you are taking electric field is equal to 0. Okay. Now, no, x is equal to 0, not electric field is 0, sorry. They are telling for taking at x is equal to 0 and its positive plate, they are asking to draw up to the 5D, that at last, how the electric field will be. So, see, we have electric field here is how much? E naught. Here how much electric field? E naught by k. Then here how much? Once again E naught. Here how much? 0. Here how much? E naught by k. Sorry, E naught. No dielectric is there. Sorry. Yeah. So now E naught by k will be more than E naught or less than E naught? Less, because k is always more than 1. Right? So E naught is the peak value. Then it reduces to E naught by k. Once again it is going to reach peak value. Then it is going to be 0. Then it is going to be once again peak value and it is going to be 0. Are you getting my point, the graph? I think you people have drawn a diagram like this. Why? Why curve? Is it gradually varying? No, yaar. Every point will have same value E naught. I saw your notebook. Both of you are sitting together, drawing same. I saw your diagram was like this, isn't it? Am I right? Marks will be 0 for that. Electric field is constant in this region. How much? Maximum E naught. So E naught value. Then it becomes how much? E naught by k. Then once again E naught. Then becomes 0 because the conductor came. And once again increases to E naught. I hope it is clear to everybody. Good question this is. 5-mark question. It comes in the. Tell me, Pratap.
Can we stop with the T naught or it should end at 0 only?
Where I have ended? Here you are saying, huh?
Yes, sir.
Yeah, you should, because the plate is ending here, no, yaar?
Okay, sir. Fine.
I have drawn from starting of the plate to ending of the plate. Understood?
Okay, sir. Okay, sir. Yes, sir.
I hope it is clear. Doubt is clear, Kalai Chairman and Varshita Shri. I hope your doubts are cleared.
Yes, sir.
Yes, sir.
Okay. So we'll take a leave now. Today's class we learned about cells. Very important lecture. Next class we are going to learn about power in series and parallel and then Kirchhoff's law. So next class will be the last class for this chapter and then we will start chapter number 4. Parallelly, in practice class, please keep on practicing whatever we are learning because we are not able to solve much numericals here. Take care. Bye-bye. Girls will leave first, followed by boys. So girls can start leaving first. Take care. Bye-bye.
Thank you, sir.
Yes.
Thank you, sir.
Take care.